Hello everyone, what's going on? Welcome back to Nilab's Tech Forge. So today, actually not today, yesterday I realized a problem that whenever I try to run any servo motor like this, there's a common problem that we are not able to find the angle, like the perfect angle on which the servo should be so that it completes the task which it's required. So basically, I was making the eye of my in-move robot. Like it's the second version of my in-move robot. Like I'm building it. You can see it has four servo motors. Okay, so yes, I was building it and I realized that the position of these motors, like these two, which control the upper and lower part for the eye to close, the position of the servo should be very precise, like if it would be one angle more or like five angle more than what's required, then the eyelids will like overlap on each other. So like I have made a program. So actually there are two programs. One you have to like upload on your Arduino Uno, and the second program you have to run it on your computer. So first of all, let's move on to the requirements. So here I'm using a PCA 9685 motor servo motor driver. It's a 16 channel motor driver, and I have provided it with 5 volt of external power supply, and you can use any servo motor. I'm using this one because I'll be running this one in my in move robot. And then you'll need an Arduino. I'm using Arduino Uno R3, and of course a burning cable and PC with Wi-Fi. So let's start by connecting the burning cable uh, in our Arduino and our PC. Okay, so now my Arduino is connected to the PC. Let's move on to the screen. Okay, so now on the screen here you can see there is a like tab named as servo angles. So this is the main code, and so this is the code of the this is the main Python program, and this will basically show us a user interface where we can name and introduce our motors to. And second we have a servo code. So this is the code which will need to upload on our Arduino Uno. So I have opened this code on my Arduino IDE, and now I'll upload this code. Just remember, for this code to work you need this library. Oh, huh? Wait, is my Python code using the no? Okay, so let's just leave that. I have uploaded my code already to my to my Arduino. So the main thing is that we'll need this library. Now you cannot find this library in the library manager. You'll need to go on any web browser and download the library from there. And to run this library, you'll need to get another library also, which is named as Adafruit Bus IO. Let me just confirm it. I have written everything in my notes. Yes, so we'll need this library, which is the main driver, and we'll need this library. So you can download both of these libraries from web browser, and then you can just go ahead to sketch include library and then add a zip library. So what this will do, this will open your manager. So you can see I have already downloaded and added Adafruit and Bus IO. So this is the code. Now let's move on to the demonstration. So this is the Python code. So if I'll run it, we should see this GUI. Okay, so now my Arduino is connected to COM5. So I'll just select COM5 from the drop down and I'll hit connect. Why is my Arduino not working? Connect. Yes, so now it has successfully connected to COM5. You can see the connected status over here also. Now what we can do, let me just remove these two motors. Trial remove motor, and I lower remove motor. So for now I'll disconnect my I module and I'll connect this servo motor. So I have connected it to channel 0 in my PCA motor driver. It is a 16 channel motor driver and I'm using the channel 0. So I'll just name the motor. So let's keep it 1 and channel 0. Okay, and then I have to specify the channel from 0 to 15 and I'll go for 0 because I have connected the motor wires, and then I'll click on add motor. So now as I'll so you can just see on this motor, as I'll move this, you can see the motor rotating. It goes up to 180 and up to 0. You can just leave it on 15 degrees, 34 degree, 47 degree, and the motor stays there. So what you can do is just try this code out, and then you can just write down the actual position. So if I want this position of my servo motor, I can just write my angle, which is 108 right now, and then I can save it in notepad or wherever I want, and then write another code of Arduino using like any AI tool by specifying this angle to it, that move the servo motor from 0 to this angle, and the motor will move. And it's not only that you can connect only one motor at a time, you can also add multiple motors to uh, to this program. Like, let me show you. Channel 1 and 1, add motor. Okay, so now wait a minute, I'll need to get another motor. Just give me a minute. Okay, so I have another motor right here. I'll just add it up quickly to the channel number 1 of the PCA. Okay, so two servo motors are connected to, oh wait a minute, why I yes, so right now two servo motors are connected to my program. I'll run this again. I guess it disconnected. Let me try connecting again. Yes, it disconnected. So I'll need to adjust the wire. Actually, I have a small wire right now, so, and my PC is away. Like, I don't have my PC right beside me, so that's the main problem. Okay, so I should be able to connect right now. Hmm. Connect. Okay, so now it's connected. Now I can show you the two motors running side by side. So as you can see, I can rotate the first motor. Actually, this is the second one. Okay, so this works, and the first motor also works. You can see the rotation, and you can add as many motors as you want. Like the motor driver allows 16 motors on the same motor driver, but right now I'm only showcasing 2. But yes, you'll see this program being used a lot because Now I have to make another robotic face. Like you can see, right there is my first robotic face, and I'm making another robotic face which has 17 motors in its face. Like this one has only 2 motors, but the next one will have 17 motors and it will be very complex. So I'll be using this program to find out the angles of the servo motor. So that's all. Thanks for watching. And if you want the source code of this project, you can just find the GitHub link in the description and just download this project and run this.